this question on Fourier series. So here we will find our period. So now these are half-wave rectifier output waveforms. So now here, from here to here, it is not a period. Here to here is not a period. It's not a period. The period is rather from here to here. That's when the signal will repeat itself. Okay. So now here I can take as my period, which is equals to 2 pi. So now here omega naught is equals to 2 pi on t, which is 2 pi on 2 pi, which is equals to 1. So now putting it into the general Fourier series equation, I'll have a into omega naught plus n is equals to 1. Okay, an cos n omega naught t plus bn sin n omega naught t. Okay, so this one, what will happen is if I say f of t is equals to a naught plus n equals 1 into n is from 1 to infinity. An, I know that cos omega naught t is 1, so cos n t plus bn sin n t, because omega naught is 1. Because omega naught is 1. So now from here, what we can also do again is that let's find our a naught. So a naught is going to be equals to a naught equals 1 over t into t naught plus t into f of t dt, okay, which is equals to 1 over 2 pi into, you see, here our waves are occurring from 0 to pi. The waves are not occurring from 0 to 2 pi. So I'll set my limit from 0 to pi. Okay, because from pi to 2 pi there is nothing there. The waves or the sine wave is occurring at 0 to pi. So I'll set my limit at 0 to pi. So if I set my limit from 0 to pi, then I'll have here 0 to pi into a is a sine wave, sine t, okay, dt, which is equals to a over 2 pi into 0 to pi sine t dt. Okay, so when I do that, I'll have a naught is equals to a into 2 pi into minus cos t, okay, 0 to pi, which is equals to minus a over 2 pi into cos t, which is pi and 0, which is equals to, so cos pi, what is cos pi? Okay, cos pi is minus 1. Okay, cos pi is minus 1. And what is cos 0? Cos 0, we know it to be what? Positive 1. Okay, positive 1. So I'm going to have minus a on 2 pi into cos pi is what? Minus 1. And then cos 0 is what? Minus what? Another 1. Okay. All right. So now here, A naught is equals to A on pi. Okay, that is our A naught. Okay, so our A naught is what? A on pi. Okay, all right. So now from here, what I can do again is I can find my AN. So my AN is equals to summation pi. Here is going to be 2 on T. Okay, here is T naught. T naught plus T into F of T cos n. Omega naught is 1. So it will be what? Okay, let me write here omega naught T, which is equals to 2, and the period is what? 2 pi into what? 0 to pi into A sine T cos n. Omega naught is 1, so T dt. Okay, so that is what we're going to have there. Okay, so now here, what we can do is, I can say that AN is equals to A on pi into 0 and then pi. Okay, into 0 and pi. So here I'll have sine. I'm going to have sine T cos nt dt. Okay, this is what I'm going to have. Okay, so now when I have this one, what I will do again is I can say that I can multiply this by 2. Okay, I can say that A on pi, okay, 0 to pi, okay, 2 sine T cos nt dt. Okay, I'm multiplying the function by 2. In that case, I'll also divide here by 2. Okay, so now what we can do from here is that we can do simplification of our trigonometric function. Okay, we can do a simplification of our trigonometric function. Okay, all right. So now we know that 2 sine T cos nt is equal to sine A plus B plus sine A minus B. Okay, so here A is what? 1 and B is what? N. So here 2 sine T cos nt is equals to sine 1 plus B, sine 1 plus sine here is what? 1, and then cos here is what? N. So sine 1 plus n. Okay, 1 plus n is 1 plus n plus sine 1 minus n. So I'll just put that one into my function. Okay, so now I'll be having an. An is equals to an is equals to a on 2 pi into 0 pi. Okay, sine 1 plus n. t, okay, plus sine 1 minus n t, okay, dt. So we will integrate this one, and then we will have a on 2 pi into, when we are integrating, let me bring this one, let me make it like this. Okay, we are integrating. So if you integrate sine, you get negative cos. So negative cos 1 plus n over 1 plus n. Okay, and then here I'll have it will be negative. It will be negative cos. Okay, so negative what? Cos. Okay, 1 minus n. Okay, let me bring t here, over 1 minus what? N. Okay, and the limits are 0 and what? Pi. Okay, so that is what I will get from that at that particular point. Okay, so now what I will get here is going to be I can input my limits inside. Okay, so let me input my limit. Okay, so a over 2 pi into the upper limit first. Okay, so here I will get minus cos 1 plus n into pi. Then here 1 plus n. Okay, then I'll have minus cos 1 minus n into what? Pi. 1 minus what? N. Then I'll also impute what? 0. So cos, okay, if here is 0, then what I'm going to have is I'm going to have cos 0. Cos 0 is what? 1. Okay, cos 0 is 1. So 1, so 1. So here is minus, and because it's lower limit, it also has a minus. So it will be what? Minus minus plus 1 over 1 plus n. Here, I'll put 0 here. Cos 0 is what? 1. So it will be what? Minus. Because it's lower limit, there's another minus attacking it also. So it will be what? Plus 1 over 1 minus what? N. So this is what I'll have when I put in my limits. Okay. So now here I'll have a over I'll have a over 2 pi into minus cos pi plus pi n over 1 plus n minus cos pi minus pi n over 1 minus n plus 1 over 1 plus n plus 1 over 1 minus n. That's all. So now let's look at something. Okay, let's look at something. Okay, so let's see the cos. So this is our cos. Sorry. So this is our cos. Okay, here is pi on 2. Here is what? Pi. 3 pi on 2. Here is 2 pi. Okay. 5 pi on 2. 5 pi on 2. 3 pi. Okay. So let's say we have cos pi minus 2. Let's say we have cos pi minus pi. Okay. So pi minus pi will give us what? 0. Okay, will give us 0. Okay. And then what is the sign of what? 0. What is the cos of 0? Here is 0. The cos of 0 is what? 1. Now let's look for cos pi or cos pi. Here, this pi here is n pi. The n is 1. Okay. Cos pi in itself is what? Is minus what? 1. So that means that cos pi minus what? Pi, which is 0, is equals to negative cos n pi. Because you see that pi minus pi is 0, so cos 0 is 1. And then cos n pi, the n pi here is what? Cos pi, because the n is 1. If n is 1, that means that cos n pi will be what? Cos pi. Okay, so cos pi is what? Minus 1. So if you multiply the minus 1 by minus 1, you get what? 1. So that means that cos pi minus cos n pi is equals to what? Cos minus cos what? N pi. Okay, and then so let's look at also another one again. Cos pi plus cos n pi. The n here is 1. Okay, so what is cos pi plus cos pi? That is cos 2 pi. What is cos 2 pi? It's 1. Okay, cos 2 pi, this is 2 pi. Okay, this is 2 pi. It's 1. And then what is cos n pi? The cos n pi here will be what? Cos pi, because n is 1. That is minus 1. Okay, if you multiply this minus 1 by another minus 1, you get the 1 over here, which is cos 2 pi. So that means that this one is also equals to what? Cos n what? Pi. Good. So now, having known that one, I can say that 2a over what? 2 pi into this one will be what? Cos minus cos n pi. So minus minus will be positive. So what? Cos n pi over what? 1 plus n. Okay, so here I'll have minus minus. Here is also minus cos n pi. Minus minus will be positive. Okay, so plus cos n pi. Okay, cos n pi over what? 1 minus n. Okay, 1 over 1 plus n plus 1 over 1 minus n. Okay, so this is what I'll get here. Now, let's see. If n, let's put in values of n. Let's say if n is 1. If n is 1, if n is here will be what? Cos pi. Cos pi, what's the value for cos pi? If you want to know the value for cos pi, okay, cos pi is what? 1. Cos 2 pi is what? Minus 1. Cos pi on 2 is what? 0. Cos 0 is what? 1. Cos 3 pi on 2 is what? 0. Okay. So you can see that cos pi is what? Minus 1. Cos 2 pi is what? Positive 1. Okay. If you want cos 3 pi is minus what? 1. Okay. Here, this place will be what? 4 pi. If you want cos 4 pi is what? 1. So now, having known this one, what we can do is if we put cos, if you put 1 here, you have what? Cos pi. Cos pi is minus 1. Okay. And then we will have minus 1 over 1 plus what? N. If we put 1 here, it will be what? Cos pi. It will be what? Cos pi. So cos pi is what? Minus 1. So minus 1 over this. Okay. So if here is minus 1 over 1 plus n, then this one will cancel this one. And here too, if you put 1 inside, you get minus 1 over 1 minus n. This one will cancel with this one. Okay. Let's put 2 inside. If we put 2 inside, you have a cos 2 pi. Cos 2 pi will be what? 1 over 1 plus n. Okay. Here, if you put 2 here, cos 2 pi, 1 over 1 minus what? N. Okay. Let's put 3 here. If you put 3 here, you get what? Cos 3 pi over 1 plus n. Okay. What is cos 3 pi? Cos 3 pi is minus 1. How do you know cos 3 pi is minus 1? This is cos what? 3 pi. You see the value is coming to what? Minus 1. Okay. So now, if you put cos 3 here, you get cos 3 pi, which will be what? Minus 1 over 1 plus n. This one will cancel this one. Cos 3 pi here, it will be what? Minus 1 over 1 minus n. This one will cancel here. So here, you can see that it is only going to be defined when we put in even numbers, like n is equals to what? 2, 4, 6, okay, and then it goes on. If you put 4 here, cos 4 pi, what is cos 4 pi? It's positive 1, okay. This is cos 4 pi. Cos 4 pi is positive what? 1, okay, it's positive 1. So if you put cos 4 pi here, you have what? 1 over 1 plus n, cos 4 pi, 1 over 1 minus n, then you can just add them. So if I put in even numbers here, then I'm going to get 2a over pi into 1 over 1 plus n plus 1 over 1 minus n plus 1 over 1 plus n plus 1 over 1 minus n. Okay, so in that case, I'll get 2a, okay, I'll get 2a into 2a over pi into this plus this, okay. I'm going to get 2 over 1 plus n, and then this plus this, plus 2 over 1 minus n. Okay, so this one, what I will get here is going to be, this one will form a difference of 2 squares, okay. This one will form a difference of 2 squares, and then what I am actually going to get, you can do the simplification, okay. You can do the simplification. You can say that here 1 plus n, and then 1 minus what? N. So if you bring it here, you're going to get 2, okay, plus 2n, okay. Please, wait. If you bring it here, you're going to get what? 2 minus 2n, okay, and then plus. So if you bring it here, you're going to get 2 plus 2 what? N, all right, and then this one will cancel this one, and then here you'll be left with what? 4 at the top. Here, if you bring it here, you get what? 1. You get 1, okay, and then this one, 1 minus what? N plus what? N into what? N times n, okay, plus, minus what? N squared, okay. So you get 1 minus what? Difference of 2 squares, okay. This is what you get, okay. This one will cancel this one, okay. This one here is squared, okay. So now here you're going to get an is equals to 2a over what? Pi into 4 over 1 minus what? N squared, okay, which is equals to, here what will happen is that we are going to have Please, we have made a slight mistake. Okay, we have made a slight mistake. Please, you realize that when we were coming, this place was what? A on 2 pi. A on 2 pi. Okay, so here I'm supposed to have, it's not supposed to be 2a. Okay, it's supposed to be what? A on 2 pi. It's supposed to be a on 2 pi. So here it's supposed to be a on 2 pi. That was a mistake. It's a on 2 pi. Alright. Here also 2 pi. So a. It's going to be a on 2 pi. Okay. Alright. So now here, when I get here, here also is going to be a. A on 2 pi. Okay. So here I'm going to get 2a on pi. 1 minus what? N. Okay, difference of 2 squares. Okay, so that is going to be my an. Alright, that is going to be my an. Alright, so now we can move on from here. Okay, so we can move on from here. Okay, so now moving on from here, we will calculate our Bn. Okay, we will calculate our Bn. Alright, our Bn is what we're going to calculate. Okay, so here Bn, Bn, before I calculate my Bn, let me write my An here again. An, I got 2a over pi 1 minus n all squared. Okay, for what? For n equals 2, 4, 6, on and on and on. Okay, and then an is equals to 0 for n equals odd numbers. Okay, that's n equals 1, 3, 5, and on and on and on. Okay, alright. So now here, Bn is equals to 2 on what? T into T0 plus T into f of T sine n T. Okay, the what? T. Okay, so here Bn is equals to 2 on 2 pi into what? 0 into pi into a sine t, okay, into sine n t dt. Okay, all right, so this is what we're going to have. Okay, so now here we're going to have Bn is equals to a on pi into 0 pi, okay, sine t sine n t dt. Wow, this is what you're going to have. So when we have this one, then what we can now do is to do our integration. But before we do this integration, we can simplify this cos further. Okay, we can simplify this cos further. Okay, so I can say that Bn is equals to a on 2 pi, okay, into 0 pi 2 sine t sine n t. Okay, so whenever you have 2 sine t sine n t, it is equals to cos a minus b minus cos a plus b. Okay, so here is going to be equals to cos, here is 1, here is n. So 1 minus n minus cos 1 plus n. Okay, so if you introduce that into the limit, then you're going to have bn. Then you're going to have bn is equals to a into 2 pi. I know you know why here I have a on pi, but here I have a on 2 pi, because I multiply here by 2. See that here there's no 2. I multiply here by 2. So I have to divide here by what? 2. Okay, so that's the reason. Okay, so here I have sine 0 pi. So I have cos 1 minus what? N minus cos 1 plus n. Okay, the what? The t. Okay, so now when I have this one, what I'm also going to have again is that I'm going to have from here I can just integrate my function straight away. Okay, I can just integrate my function straight away. So I can have bn is equals to a on 2 pi into sine 1 minus n. Okay, please, here is t, here is t. Okay, t over what? 1 minus n. Okay, and then here I can have minus sine 1 plus n over 1 plus n. Okay, so this is what I'm going to have. Okay, so 0 and then what? Pi. Okay, so 0 and then pi. Okay, so now here what I'm going to have is going to be sine bn is equals to a on 2 pi into sine pi minus n pi. Okay, 1 minus n minus sine pi plus n pi, because here there has to be t here, n pi, okay, over 1 plus what? N. So that's introducing what? N into the limit. Now let's see 0. So here, sine 0 here, sine 0, if I put 0 here, the whole of this one becomes 0, because sine 0 is 0. Now if I put 0 here, the whole of this one becomes 0, because sine 0 is what? 0. So that means I have to end here. Okay, so now there is something we have to remember, that just very similar to what we have with respect to the cos. Okay, what we have with respect to the cos, whenever we have sine pi minus n pi, okay, it is equals to sine pi, sine n pi. Okay, and whenever we have sine pi plus n pi, it is equals to minus sine n pi. Okay, so just as the way we prove with the cos, you can also take the sine wave and then prove this one also. Okay, all right. So now you have to know that. Okay, so now let's come back to this equation that we just got. Now, with respect to this equation, there is something that we can do. Okay, again. Okay, so now let's say that I am putting in values. Let's say I put in the value 0. Oh no, because we are always starting from 1. Let me put in what? 1. Okay. Let's say I put in the value what? 1. So that means that 1 minus 1. 1 minus 1. It will be what? 1 minus 1 will be 0. Any number divided by 0 will be what? Infinity. Okay. Any number divided by 0 will be what? Infinity. Okay. If I put in 1 here, 1 minus 1, it will be 0. No matter the number here, okay, it's going to be infinity because 1 divided by any number will be infinity. Now, let's say that I put in the number 2. Okay. Let's say that I put in the number 2. Okay. So now, if I put in the number 2, then what it would mean is that I'm going to have sine pi minus n pi. Okay, sine pi minus what? N pi. Okay, so what is that sine pi minus n pi going to be? Okay, so already I just wrote that sine pi minus n pi will be what? Will be what? Sine n pi. Okay, will be sine n pi. So now, if I put in any other value like that, then I'm going to have Bn is equals to A over 2 pi into sine n pi. Okay, n pi over 1 minus n. Okay, here is going to be what? Minus minus. So this place is going to be what? Plus. Okay, so plus sine what? N pi over what? 1 plus what? N. Okay, so if I put in any other value like 2, so I'll have what? 2 pi. Okay, I'll have 2 pi. So sine 2 pi, what is sine 2 pi? If I want to know sine 2 pi, what I can do is that I can just bring my sine curve. Okay, I can just bring my sine curve. So where is the sine curve? This is the sine curve. So this is the sine curve. Okay, so here is 0. Here is what? Pi. Here is what? 2 pi. So here is what? 3 pi. So here is what? 4 pi. So now, if I have sine 2 pi, sine 2 pi, what is the value for sine 2 pi? It's 0. Okay, it's 0. So here to sine 2 pi will be 0. Now let me put in 3. If I put in 3, I'll have sine 3 pi. What is sine 3 pi? 0. Sine 3 pi, 0. Here, if I put in 4, sine 4 pi. Sine 4 pi is 0. Sine 4 pi is 0. So now, apart from 1, which will give us infinity, any other number, okay, will give us what? 0. So, Bn, okay, Bn is equals to what? Infinity. For what? N equals to what? 1. Okay. Otherwise, Bn equals 0. Okay. So that means that Bn equals what? 0 for any other number. Okay, so that means that B1, okay, is equals to what? Infinity. Okay, so that means that B1 is equals to what? Infinity. So now, if B1 is equals to infinity, then we can get an equation for what? For B1 alone. Okay, we can get an equation for B1 alone. All right, so since B1 alone is equals to infinity, then I can say that B1, okay, is equals to A over what? Pi, okay, A over pi into 0 pi. I'll go back to the original equation, okay, sine what? T, okay, into sine what? sine t into sine nt, but here n is what? 1. So I'll say sine what? T, okay, dt. So this is the equation that I'll have for only what? B1, okay. It should have been sine nt, but n is 1, so sine what? T, okay. So now, when you have this one, then it is equals to a over pi into 0 into what? Pi into sine squared what? T dt. Okay, so you're going to, this is what you're going to have. Okay, in that case, B1 is equals to a over pi, okay, a over pi into here 0, here pi, okay. We're going to have 1 minus cos squared t, okay. 1 minus cos squared what? T over 2, okay. So dt, okay. So sine squared t, if you expand it, okay, in terms of trigonometry, this is what you're going to have, okay. So now what we can actually say from here is that we can have 2 to come outside, okay. So b1 is equals to a on 2 pi into 0 into pi into what? 1 minus cos squared what? T dt, okay. So now if you do this particular differentiation, then b1 is equals to a over 2 pi into t minus, because if you integrate 1, you get what? T, okay, minus sine, okay, sine what? Sine t over what? Over 2, okay, over 2. Let me bring that 2 here. 1 over 2, okay, sine t over 2, okay. So basically, that is what we're going to have here. We have made a little mistake here. Please, this place is not squared. It's 2t, right? So sorry. Okay, it's 2t. Okay, so here, if that place is 2t, that means that here I'll get another word. Here also become 2t. So sine 2t. Okay, this is what I'm going to get. So here I can put in my limit, which is what? Pi and then 0, which will give me, if I put pi here, I'll get a over what? 2 pi into what? Pi minus 1 over what? 2 into what? Sine 2 pi. Okay, let's see here, I'll have what? Sine 2 pi. Okay, then if I put in 0, here will become what? 0. And then here, if I put 0 here, here also become what? Sine 0 is 0. So here become what? 0. Okay, so now that means that what I will get here is that, what is sine 2 pi? Sine 2 pi, basically, sine 2 pi is 0. Yes, sine 2 pi is 0. Okay, so that means that here becomes what? 0. And I'll multiply here. So that means that b1 is equals to what? A on 2. That's our b1. All right. Yes, that's what you're going to get for b1. Okay. So now, if we know that this is going to be our b1, then we shall progress. So now here, what we're going to do again is that we're going to do f of t. So f of t is equals to what? A naught plus summation into infinity, n is starting from 1, into what? An what? Cos nt. Okay, it's supposed to be omega naught t, but omega naught is 1. Okay, so it will become nt. Okay, plus bn sine n omega naught t, but omega naught is 1, so I'll just put t here. Okay, so this is supposed to be our expansion. So this is for what? T naught into what? T into what? T naught plus what? T. So in our case, we got f of t to be equals to a naught. What was our a naught that we got in this particular problem? Okay, it's not a problem, it's just a solution. Okay, we got what? We got t naught to be what? A on pi. So I'll write here a on what? Pi. Okay, and then we also got our b1. And then, okay, so let me see, a on pi. Let me bring the summation here. Okay, n is equals to what? 1 into what? What did we get for an? Okay, an, what we got for an was this one. We got 2a over, let me see what we got for an. Okay, so an, what we got for an? Okay, so an we got 2a. Okay, this is what we got for an. 2a over what? 2 pi. Okay, 2a over 2 pi. All right, into 2a over, sorry, it's what we got was a 2a over pi. Okay, sorry, 2a over pi. So let me write here pi. Oh, sorry. So 2a over pi into what? 1 minus n what? Squared. Okay, all into what? Cos nt. Okay, all times what? Cos nt. Okay, then we got bn. Okay, but actually our bn was not a summation, because the bn we got was what? b1. Okay, was b1. Okay, was b1. All right. So now here, let me write it here like this, just to show you that the b we got was not bn, it was b1. So here I will say that it was b1, and then b1, what did we get for b1? Okay, b1 we got what? A over 2. Okay, so I'll just put here plus a over 2. So if I'm writing it well, and if I'm writing this one well, then I should say that it's equals to a on what? Pi. Okay, plus a on what? 2, because the summation doesn't affect this one. It's a single number, so the summation will not affect it. Okay, plus summation here, infinity, n is equals to what? 1. 2a over what? Pi into what? 1 minus what? N. Okay, squared. Okay, cos what? Nt. Okay, so this is what we're going to have. Okay, so from here, basically, this is what we're going to have. And then from here, you can see that here, this place, basically, what we got here was that it was defined for what? I think it was defined for even numbers. Okay, then you can put your limit here. What was your limit? It was from 0 to what? T to what? To pi. Okay, so basically, this will be the solution for this work. Okay, I leave the expansion to you as a homework. You can try that one at home, the expansion. Thank you so much. See you in the next class.